Hello guys, and welcome to the second part of the electrolysis video, where we're covering the electrolysis of aqueous solutions. Okay, so what do we mean by aqueous solution? Aqueous solution means that this is the symbol usually to represent aqueous, AQ. Okay, which means that there is a presence of water. So that means you're dissolving a solid in water. So when you dissolve something in the water, that means it is the compound but in aqueous form because it's mixed with water. Okay, so from here we can tell that the products of electrolysis will also change because water itself produces its own ions. What are the ions? H plus and OH minus ions. So H2O will dissociate into H plus and OH minus ions. Okay, so we might be a little confused. So what will discharge? H, OH, or the metal, or the gas, the anion. What will dissociate? So that's when the reactivity series comes in play. So this is a different reactivity series right here. So we have the cations here. We have a long list of them. We have the K plus, Ne plus, Mg plus, 2 plus, all these cations. All right, so I have a little arrow here that says the tendency to discharge increases downwards. Okay, so this is where H is. So let's just focus on this H right here, because this is the one that is going to cause all the problem, the H plus. So any metal above H plus will not be discharged. Okay, so that's the key here. You must remember, any metal, so K plus, Ne plus, Mg2 plus, La3 plus, zinc 2 plus, iron 2 plus, tin 2 plus, lead 2 plus, all will not be discharged. Okay, and the metals below H plus, Cu2 plus, Hg plus, Ag plus will discharge. So this is pretty simple when it comes to memorizing this part, because all I have to memorize is just the ones under here, because only these will discharge, the rest will not discharge. So that's a conclusion we can draw from that part. So now the anion part. Who will get discharged here? The OH or these? And the answer would be OH. Every time it will be OH, but there is an exception I'll talk about in a bit. But otherwise, on normal circumstances, we have the OH to be discharging first because it's at the lowest point in the reactivity series. Okay, so like I said, there's the exception. However, the exception for anions is if any of these anions are more concentrated than OH, then they will discharge. So that is the exception for anions. If they are more concentrated than OH, then they will discharge. So and also the last thing is that types of electrodes also play a role in the products. Okay, if you use carbon, okay, let's take an example here of CuS SO4, so it's copper sulfate in an aqueous form. Okay, so it's with water. We're gonna do this electrolysis with carbon electrodes. So if you use carbon electrodes, OH will discharge. Basically, carbon dioxide gas will be produced. Okay, but if you use Cu, or basically copper electrodes, Cu2 plus will be released as a form of ion into the solution. Why? Because this has a tendency to form, so this also has a tendency to release. Okay, so that's basically all we have to cover for electrolysis of aqueous solutions. Very, very simple, not that hard. All you have to remember, main thing is this big chunk right here, the cation anion reactivity series, and you're pretty much good to go with electrolysis of aqueous solutions. So guys, again, as always, If you guys find this video helpful, please show your support by thumbs up, hitting the thumbs up button, and feel free to comment on any video you would like to see in the future. So till we meet the next time.